Hi and very good morning to all of you here, and it's a pleasure and honor to present this topic, enabling data governance with text analytics with the AI. It's a topic very close to my heart, and I'm sure many of you in the audience already well experienced or exposed to this topic one way or the other. But still, there are some projects which we experienced recently in my organization, and some interesting exposure to how we deal with this text analytics and integrate it with the data governance. So I'm going to share that with you today. So quick introductions. I'm currently with ProcFox. We are a B2B platform company, and previously with the SAP Group as Director of Data Science, and before that with the Abu Dhabi Water and Electricity Group as IT Projects Manager. So spent predominantly most of my life with dealing with data one way or the other, and typically more so in the unstructured data domain, and the past couple of years now in the data science field. So today we'll start off a little bit of some theory and concepts. We'll try to not make it very boring. Business background, problem definition, discuss a little bit about the technical aspect. So the interesting thing that I want to do today is actually talk to you about the live business use case with actual data, and how we solved a very interesting text analytics problem. And then after that we'll have some Q&A, and hopefully I'll be able to answer some of the questions. Please feel free to interrupt me anytime, and we can take the questions as they come. So data is I think all of you in the audience, one way or the other, we're all dealing with data. But the question that comes to most of us as data scientists, data professionals, any field of IT, is that what is good data, what is bad data, how good is the data that you're using? I say that a data scientist spends anywhere from 50 to 70% of his or her time dealing with data preparation, data quality, and data cleansing related activities. So data is really important in terms of having the right quality and the right inputs before we start building our models and deploying them. So with that in perspective, a little bit about data governance. So data governance is an all-encompassing body which has at least 12 principles related to it, starting from data architecture, modeling, design, storage, operation, security, reference, and master data. So those of us in the data field, information governance field, we're actually using a reference called DMBOK. So how many of you in the audience are familiar with DMBOK? Great. So I'm very happy to see that. So generally when we start talking to customers and clients, there's a lot of ambiguity or confusion between what is data quality, data governance, information governance, and most often we feel that these are terms which are used interchangeably. So just to set the context, data governance is the overall management of the availability, usability, integrity of the data, and a sound data governance program includes a governing body or council. Data quality, on the other hand, uses certain dimensions to measure or score how good your data is for consumption purposes. So we look at accuracy, timeliness, completeness, consistency, and so on as metrics to measure the data quality. So data quality itself is actually one of the dimensions of the data governance aspect, and we use more or less in all our projects we use DMBOK as a reference guideline to implement it. Dwelling a little bit on data quality, so if we were to think of data as water, so data quality ensures that your water is pure, it's not contaminated, whereas data governance make sure that the right people with the right level of security access, right level of information access have, it provides a framework to ensure the quality. So these are two separate aspects, and basically a data quality implementation pipeline typically includes a cleansing process, standardization, matching, profiling, and so on. And these solutions actually help to maintain and improve the overall quality of your data. One interesting metric that we also use is what you call as analytics maturity quotient. So when we're trying to do modeling, so it's build a machine learning model, or we're trying to do some dashboards, visualizations, descriptive, prescriptive, predictive analytics. So data quality is very important, and one of the interesting quotients that we've used is the AMQ, which is a patented metric, but we've used it in some of our projects. what we're using here is a data quality as a multiplier. So you see that it depends, it's a multiplier, and then we use metrics like the data definition, the people, and the implementability of your model itself. So data quality is a very important aspect which actually results in a good implementation of your data analytics project. So before we move further, dwelling a little bit on the data governance, DQ and AI intersection aspect, right? So data quality is a prerequisite for a good machine learning project implementation. So we're looking at missing data, inaccurate data, or spelling characters. This is typically part of our data preparation phase in an ML project. On the other hand, the data governance, on the other hand, is a consumer of good data, and then it ensures that we have the right data quality, the master data and the reference data, the security aspect which is implemented through a data governance program. So this is actually an ongoing cycle. One of the fatal mistakes that we often make is in a data governance or a data implementation, analytics implementation project is the fallacy to assume that data quality is a one-step process. It's not. It's an ongoing cycle. To consume the right data, we need the right processes to ensure the data quality is good. The data scientist or data professional ensures the data quality is good for consumption for the model. And once the model has been built, it is ingested back into your information governance life cycle, which has many challenges. So you have heterogeneous data, you have unstructured content, you have big data, social media, and also your enterprise data lake architecture. So there is a complex cycle which is there, and this is necessary. An ongoing cycle on the front end to make sure that the data quality is good, and at the back end to ensure this governance is an ongoing process. And also talk about text analytics. So how we're using text analytics as a process, as a medium to implement data governance and data quality. So typically text analytics is a very vast topic, and I think if you want starts talking about it, you can spend a lifetime. This is a very huge topic these days with multiple applications. So my experience in this is specifically related to how we use DQ for this implementation, but yes, pattern recognition, sentiment analysis, topic modeling, data mining, visualization, predictive analytics, a whole lot of applications there, and how we can use natural language processing actually to implement this is a huge interest area in itself. So in today's discussion, I'm taking two specific use cases, which is actually related to business challenges that we faced as a project implementation partner for some of the data quality related projects. One is that a retail store that we've been working on had huge issues on operational data quality. A global network of stores, multiple users, stakeholders using multiple systems across the globe. Maintaining accuracy of the data was a huge challenge, and misplaced inventory and duplication of the effort, this was consistently reported. On the other hand, we also did a little bit of data governance implementation for a manufacturing MRO kind of company. Maintenance and repair operations spread throughout different parts of the country and parts of the world, and different stakeholders entering data into different enterprise asset management systems. And over time, this lack of standardization became inconsistent, very difficult to control. So we will focus today on actually one particular use case and see how these data quality issues actually necessitated an implementation of a ML-related project on analytics. So data touch points in the manufacturing supply chain, so that we have internal data sources. So you have supplier data, vendor data, you have ERP, PLM data, you have spreadsheets, legacy applications, both structured and unstructured. And you have external data consumers, so you have all your social media and trading partners, catalogs, sales sheets, CRM, customer-facing applications. So basically the internal data validation mechanism is an ongoing one, from syndication to planning to matching to standardization. It's an internal ongoing process. And this complex process has to be there to ensure that we have the right data at all times. Another aspect is the multiple sources of truth. So typically MDM, master data management, data governance systems deal with having a single source of truth, or the golden truth, which is coming from multiple enterprise assets like your product data, your vendor data, customer data. All these data coming from multiple sources are integrated, but at the same time your enterprise asset management has a complex responsibility to ensure that a single source of truth is maintained. So we discussed how the business imperative or the business context relates to creating multiple sources of truth. One interesting question that often comes is, if we have so many systems related to governance, if we have MDM, if we have data quality systems, if we have database schemas and standardization, why does data quality issues, why does bad data still happen? Typically that when we see that these customer facing and stakeholder facing applications, typos and misspellings, changes in source systems, data migration and conversion of data from legacy applications, different levels of expectations and standards used by. This is classical case in manufacturing companies where we work. We see that designation standards for the same product part, at least 5 different type of data description actually exist. So the buyer enters one kind of description, the supplier enters one kind of description, the internal purchase engineer enters one kind of description. So there are multiple sources and consumers for this data, and data quality is an ongoing issue between multiple stakeholders. So what does really happen at the end of this is that employees and stakeholders, they become quite frustrated, attempting to search for items in the catalog with non-comparable descriptions, duplicate items, creating issues for warehousing. So if you have a table described in 10 different ways, so how is the purchase engineer actually going to make sure that that stock or inventory item is properly catalogued and then passed on between data extraction, ETL process and data loading. And then there is also a human interaction aspect. So the source data is coming in from multiple sources, the target system, master data governance and other databases. There is a continuous cycle of extraction, transmission, loading and, and then final input to the target system going on. At this, there is multiple forms of interfaces also. There are data dictionaries, there are data catalogs, there is metadata, schema integration. So all this is a typical architecture of how a DQ system is implemented. So as you see the overall life cycle of a data quality in terms of discovery, profiling of the data, implementing certain rules, data remediation and data quality reporting. This is an ongoing cycle of a typical data quality implementation. So data quality process in typical implementations, we look at 3 things, right? We look at the schema definition, we look at extract, transform and load, and we look at data standardization. So for a schema, for data to be well defined, we need to have a schema. Your backend, your tables need to have the schema of the data that is going to be purchases, orders, customers, products, etc. Once target data schemas are agreed upon, you do an extract, transformation, load and standardize the data. But this is a disadvantage because increasingly we're dealing with big data solutions. So we have data at rest is addressing only data at rest. What about the data in motion? Focus only on master data, which is like pertaining to things like products and services. So what about ongoing social media and big data sources? So these are, and limited number of systems. So these are some of the disadvantages that data quality processes tend to, and we are moving away from that into a more dynamic approach where we integrate ML and AI systems into this process. So when we talk about data quality, I think most data professionals, you know that typically we talk about 4 of 6 areas of, which is completeness, conformity, consistency and duplication. And this is very, very typical for any large information systems project. Typically we tend to focus on completeness, conformity and duplication, and especially in the data science, the duplication aspect, ensuring no missing, no null and consistency. This is a huge prerequisite for most ML model building areas, but even for other projects like enterprise content management, metadata management or business analytics or master data implementation, ensuring these 5 dimensions of data quality, this is a very important aspect. Some examples, this is an actual example from industry use case where we've seen that, for example, you see that the same data is spelled in a different way. So there is lack of conformity in in suppository and SUPP. And a lack of standards. Consistency has to do with lack of standards. So you say that the same data which is coming from different manuals, different production manuals, inventory manuals is expressed differently here. And then there is duplicacy of the same data, which is like just a small misspelled or typo causing a duplicacy of data. So this is actually sharing with you, this is actual data from the enterprise asset management systems, and this is even in spite of implementing the data standardization and the data schema, these kind of data quality issues do happen. So we have persistent issues in conformity, consistency and duplicacy and so on. So coming to the text analytics part, which is what this talk is really about, and how to deal with these kind of data quality issues in a machine learning context. So you see the text in red above is actually the raw data input from a purchase officer. It is from who's trying at an MRO center and a manufacturing setup which has large worldwide operations. He has input certain text which is it's a raw text description, free text description, and this needs to be checked against dictionary reference and then finally understood as clean, consistent, conformed data to be able to be used by the end user. So why is this a challenge for us, and why is text analytics going to be used here? So as I said in the previous part of this discussion, so raw data is really coming in from suppliers, vendors and purchasers from, it is not really matching any data roots as such. But internally what we have is a data dictionary reference, which is like your Bible, so to speak, a data catalog or a Bible, so to speak, which tells you that your product should have description of this type. So the noun is actually the product type, modifier is your product subtype, and characteristic is a further description of the product. And the values of these are actually the metadata. So let's say if you're talking about some industrial machinery good, the width, the diameter, these are actually metadata which describe the data in further detail. So text analysis challenge really in this case is to take the raw data on top, match it against the data dictionary reference, and then to be able to parse it, chunk it, and classify this data into recognizable elements into your target labels. So here actually we're talking about a in machine learning terms, we're talking about a multi-label, multi-class kind of classification challenge, and this is what we felt is a better way of handling it, because the information extraction is a traditional way of data quality management was really very slow and cumbersome. So if you look at the journey of the data itself, which is starting from the top, which is like this is your raw data, which is how it looks like. We do a dictionary match against existing internal data dictionary or data reference catalog systems. Move on to a semi-structured data interface or a staging area where data is now parsed and understood into a semi-structured format. And then we classify this data into the specific labels, so which have product name, product type, product description, metadata, what is your character values. And then finally, the final stage is to understand the data quality, the data cleansing or enrichment. So if you understood the data is bad, you managed to parse the data, the raw data, you managed to classify it and label it. Now we understand these, this data in terms of the data quality dimensions, the consistency, conformity, accuracy and so on, which we discussed earlier. And finally, once this data has been understood this way, we push it to your master data governance system. So this is again an ongoing cycle, and the text analytics challenge that we addressed, we use this approach, this pipeline, so to speak, to take text from a very raw, unstructured level to a final intelligible, recognizable level which could be used for the governance. So from the platform perspective, we've used Anaconda and some of the Python packages like NLTK and scikit-learn was a big last matplotlib for the reporting, and Jensen and NumPy as well. Talk a little bit about the text analytics process itself. So as I spoke about this in the previous slide, so vendor customer systems coming with disparate data, raw unstructured data, and this green block here is really the text processing pipeline. So we start with a information chunking or extraction process. We perform certain pre-processing activities. We'll see what they are. And then tokenization, lemmatization, and stemming. These are typical text analytics related aspects. Building a bag of words or a tokenized model, and from the bag of words model we go on further to build a supervised classification or metadata mapping. The output of this, as I explained in the previous, is to come out with a data quality or report which is cleansed. And then finally, when the data quality has been understood and we've classified the data, we push that to your data enrichment and governance aspect. Any questions so far? Yeah.
I just want to understand how this model would deal with and field or have missing data into my raw data. How will that deal with?
Sorry, missing?
Yeah, if I have missing data in my raw data, so some fits among them, how will the model deal with that?
So yeah, so basically, yeah, I'm dealing with this in two ways. One is that the missing data itself is a data quality aspect. So when I say, so I'll actually come to that. So when you see the final classified data on the right side, you have material number, material description, and so on. So we arrive at this stage by getting this raw data. So the purchasing engineer at the MRO office or the field engineer is actually giving me this huge bag of words, which is like just a big, like a rubbish mishmash of terms like this. But we don't know from this what exactly he's trying to say. What is the product part that he's trying to order? Is it like a gasket or a wall or flange? So we need to reference this against the data dictionary and then be able to classify this into the proper structured text format. So this is like a classification. But yes, so we will come to that. Typically in machine learning languages, what we have is structured data, typically with rows and columns. You have the parameters, you have customer name, order, product, description, or you have, for example, product data, customer data, or any other kind of data. We typically have rows and columns, we have a structured data format. But in text analytics, the challenge is different. We have to extract, tell the model that this is actually, this text actually is mapped to a feature vector. So feature vector extraction is a typical complex part of this. We do it using n-grams processing and TF-IDF. We'll come to that. So in the text pre-processing depth also, as I was saying, the classifiers and the learning algorithm, they don't directly understand what a text document is all about. So my text document is basically a Word. It could be a Word file, it could just be a .txt, it could just be a badly written paragraph. So this learning algorithm, this ML algorithm, it cannot process this text directly. So during the pre-processing step, we use something called the bag of words model, where we create a token. We imagine that your entire word set is going inside a bag and each word is assigned a token. So we tokenize these words and then we create a feature vector out of these tokens. And once we do that, we are able to actually train this model and then predict what the classification output is. So you see on the left, this is actually a sample data, which is actually for a supervised classification model. So we have noun, modifier, and input data. Noun is actually your product, modifier is like a product subtype, and input data is a product description. Our challenge text analytics channel is to be able to predict the noun, modifier, and character values based on training data. And to really understand how supervised classification works, whether you're using logistic regression or linear or SVC, random forest or any other model, the challenge really is to be able to classify the data based on some training data, right? So in this case, text analytics again faces a huge challenge. One is that this kind of labeled data is rarely available to us. It is very rare to get this kind of clean data. Second, actual data is far more unpredictable. So if I get this data here, I may just get one line or two words from the purchasing officer or field engineer. So how will I know whether he's referring to a gasket, he's referring to a wall, he's referring to some other machinery type, just with two words of input data. So that is a real challenge, that actual raw data is far more unpredictable, no matching data or values. imbalanced classes. So this imbalanced classes is a huge a challenge also in most ML projects. Definitely text analytics is no exception. So when we have a huge training data, 70% of the data talks about only one kind of product type. So when you start using this training data to test it on actual raw data, you find that your results are quite fairly unpredictable. So moving on, let's understand what the data is all about. So data, in this case, the raw data that we have is actually having this hierarchy. There's a source description, the product, the modifier, and this has various attributes. And on the right side, you see a sample of this data hierarchy. And this is how our actual raw data will actually look like. This is like raw data which is coming in from the field. So my text analytics challenge is to take this and to be able to predict these values on the right side, to do a multi-label, multi-class kind of classification. So we faced a lot of challenges in this kind of a classification mechanism. What is it that, to answer your question, missing metadata is a huge issue. Character values of it missing. Sometimes you get totally new identifiers. So what do I mean by identifiers? So I have basically mapped my data dictionary based on product, modifier, attribute 1, attribute 2, attribute 3. And a typical example of that is there is a bearing, the product subtype is ball. It has some parameters like diameter, clearance, gauge material, and so on. I have trained my data, I have trained my training algorithm based on this kind of data. Now what if I get some data which has totally new fields it has never recognized before? Then the third aspect is managing complex word association, paradigmatic syntagmatic associations. Sometimes there are 2 or 3 words which always occur together, right? Sometimes gasket is also called ball, sometimes piston is also called ring, right? So how do I deal with this kind of situations in the modeling process? The fourth challenge is intelligent discovery of potential dictionary matches. So your data dictionary tells you that this is your master list of data, this is your master list of text, but can I really use that to intelligently say that some new discovery can be made? So that is one of the other challenges of matching. And the fifth challenge is predicting the short and long description of this data. So once this data is actually classified and labeled, can we do a short and long description prediction? So if I say only gasket and ball, can I predict diameter? Can I predict height, width, and so on? So this is another challenge that we faced from the clients. Second challenge is the complex and dynamic business rules in text analytics. So for example, in this case, this is the kind of rules that we get the client. We say that in case no nouns are detected, some modifier is detected, this should be highlighted. Or we say double noun, so it has 2 or 3 nouns, product types. So your text input data is talking about 3 product types in the raw. So how do I know what product type this is actually about and what should I take? Okay. And then, totally wrong combinations. So though the casket can only have a product type of ball, sometimes we get totally mismatched combinations. So complex and dynamic business rules and the data itself is a huge challenge in the text analytics. And the third is of course the imbalanced training data that I talked about earlier, a huge skew towards certain data types only. Let's say for example, your training data set that you're given, that you have in your MRO catalog or internal inventory database, it only talks about wall, gasket, and switch and fuse. If I were to try and use this data catalog or inventory database to try and predict or classify new, it will actually give us an erroneous result because the data is actually, our training data set is highly imbalanced towards only certain hypotheses. So this is one step in the topic, the text analytic process is the extraction of the bag of words and the n-gram extraction. So I explained in the previous text analytics pipeline that one of the text pre-processing steps is that we take the actual raw data and then we extract this words list from the raw data. So we actually see that from your this highly unstructured paragraph of 10 or 20 lines, we actually extract each of these words as a token and then we find the number of occurrences of those words. So the left column is actually the the data, the token itself, and the right side is the number of occurrences in the document. And what we call is, as a very important step in the text analytics process, is the n-gram extraction. So what we do is, for example, say suppose you have to do a sentimental analysis on a text analytics. We find that vehicle and car is always occurring together, or we say that ice cream and summer are always occurring together. So we find certain words which are highly termed, which are highly correlated, and these correlations are used to find out and predict what can be the possible values. So for example, in this case, we did a unigram and bigram, and we found that forklift, forced lubrication, forklift manufacturer, zinc plated, these two words are occurring together very often. And then similarly for the product description, part number, information info, PO text, these kind of information, this kind of data is occurring together, and they have a high degree of correlation. So the n-gram actually helps us to identify high degree of correlation between certain words, and this actually helps us in the semantic modeling to predict. So if I say ice cream, then I can also say that summer is somewhere part of the material description, just to take an example, right? So driving license. So these two words are occurring together, the high degree of correlation. So we identify what these are called the n-gram, bigram, and in the TF-IDF feature vector description, we can actually specify your n-gram. So it can be a unigram, it can be a bigram, it can be a 10 gram. So you can actually scale up your n-gram description itself. So this is a very important step in the text analytic process, is to extraction of this. Once this information has been extracted this way, we are actually then mapping it into our semi-structured format. If you recall the previous slide where I had spoken about the text analytics pipeline, where we are moving from raw to dictionary checking to semi-structured, we then arrive at the semi-structured. After doing the bag of words in the n-gram, we are able to take it to a semi-structured state, where you have a predicted noun and a predicted modifier, and the short and long descriptions, right? So short and long descriptions, which will actually come in from our n-gram model. So the final classification output, the end result of this project in terms of how to take raw unstructured data and to do a multi-label, multi-class classification. This is how it actually looks like. So out of this huge piece of junk data, that the raw unstructured data that I get it, I'm actually able to predict what is my product, what is the product type, what is the description, and all the other parameters related to it. So this is an important achievement in terms of how a machine learning approach can be used in terms of predicting, rather than just a pure information extraction using a Python program where we actually loop into the data set and pick and choose the words. We're actually using a model to predict the values. So the final output also, this is another sample, and your DQ scorecard also looks like this, where we talk about a dashboard which gives my completeness, duplicacy, and consistency and output. So looking at the output data here, we are actually looking at how many items are duplicated, how many items from this are consistent, how many items from this actually conformed to the data quality standards or internal specifications. And then this kind of a data quality output actually goes to your asset manager, purchase engineer, or other internal consumers. So the final step of this is also actually the model performance comparison. So as I was saying, we started with modeling is far superior to a native approach in data quality, where we are actually able to take raw data and actually predict the final output. So in summary, I would like to say that in any data project, whether it is a data quality or data governance or information management or business analytics, predictive analytics project, we have to identify the key data points that are most important for us, the key piece of information that we care about the most. Determine which user system will be your master. So there will be customer master, product master, inventory, enterprise asset management systems. We need to really understand where the most important part of the data which is useful for our company consumptions. So today we have many platforms. We have Alteryx and Tableau and click view for business analytics, and we do the data prep and data quality even in that stage. But really we need to understand which is the data source which is most important for us. The third is to determine really who owns the data. So the owner is the group that has a business ownership. So in many cases it is not the person who is the source, the creator of the data, but who is actually the owner of the data from the maintenance point of view, which actually brings me to the next point, which is the data steward. And in the information governance programs, we do have a data steward who ensures that the information is maintained accurately and correctly at all stages. And then finally is to have a data framework. I was talking about this in an earlier slide where we said that data quality is not like a one-stop, it's an ongoing process where we need to continuously maintain the cycle from ingestion to cleansing and to final consumption. So it's not a create and leave it program, it needs constant nurturing as new data points are added and new business needs. So with that I think I will conclude, and if there are any questions, please.
It's very interesting from a point of view because I dealt with this type of data for too much time.
Yeah.
One thing I noticed respect to the approach I use generally. I don't treat the data let's say so specific. I treat more documents, but comparing the two problems, I had the impression that what I take is more an approach of leverage the context of to classify the document. Yes. While here, I think, at least from what I understand, you are trying to classify it from just the, let's say, the information into the label.
The right.
So I wonder if you bring in this context into your let's say methodology, and how.
The context of the data itself.
Yeah. For example, I dealt a lot with engineers, so this about gasket is a paramount example, no?
Yeah.
But I know for sure that if I look at the 1,000 row where there is an input data calling a gasket, 800 are wrong, are not standard.
Exactly.
And these 800 probably 90% have been inserted by the same person.
Exactly.
Okay, so the context here is knowing that this same person will misinput the data.
Yeah.
No? So this named person is an input in your analysis or not? This to understand. Give an example of context data. No?
So I think this is a very important question, and we really dealt with this issue that, see, no machine learning platform can be 100% automated. It cannot be a 100% automated solution that when we're trying to do the accuracy. So we came to a very interesting situation where we had all these set of business rules here, right? Okay, so we sat with the engineers, we sat with the asset engineers, and we said, okay, if this is the rule and we can automate this, can we, logically speaking, we should actually, our machine learning algorithm should, logically speaking, understand all the context and should be able to give me 100% output. But it turns out that the data dictionary, the data catalog itself is not like a foolproof 100%. It is like an ever-growing source of truth. So today, for example, the field engineer, there is something called the semantics and the linguistics. You as an engineer know it. So WAL itself has 10 different semantic associations. So that's why in our program, we have incorporated what we call as the synonyms also. So for the WAL itself, to create more context to it in terms of automating the machine learning, we've created 100 different synonyms for this, 100 different what you call as fuzzy enabled searches which will actually detect any variation of gasket. So gasket can be spelled as GSKT and gasket and GSK for, because engineers, they input it any way they want. They will not follow a certain standard rule. So to make it more contextualized, we try to automate this along with the business rules. We try to automate this and include.
But for example, what I mean is,
Yeah.
sorry.
Yeah.
This is normal, no? I mean, having synonymous dictionary is normal, but still is approaching the data looking just at himself.
Yeah.
No? What I'm preferring is more about the metadata. For example, bringing in that this data has been inserted in a certain moment, or in a certain season, or in a certain project, or through an email instead that through a website or a form or something like that.
Yes.
So all this set of metadata can contextualize the input.
Yes.
So I wonder if you are bringing this
Yes.
set of metadata into
Yes.
this analysis.
Yes, it's a very good question, and actually we have thought about this even in our cycle here. So when we are actually looking at, I think I will take the other picture too. So here actually the data dictionary, as we saw, is one source of contextual reference. But when you say that, you know, all the social media, the web forms and the customer inputs and from various other data. So we build a continuous loop where the machine learning model retrains itself. It is ingested back into the training as well as the data dictionary. So it's like a live organism. We are not saying that, okay, gasket should only be like this, wall should only be like this product, and these are the only metadata. So the intelligent part, the good part about the machine learning approach is that even after classifying the data, the model can be retrained. We continue to retrain the model with the newly understood source data aspects. So I think I wanted to talk about this. So it's again in context. So if you are like a BI user, let's say Tableau user, QuickView user, or any other reporting user, and I want to report on customer sales for the next 3 months on against a product, so it's a cross-tab kind of reporting. So I would typically, as a data BI developer, I need to look at the missing and the inaccurate, the spelling, and these are the typical things, the null value, the missing value checks that we do as a data prep stage, and that has its own relevance in terms of the data context. So I would be using only that data which is relevant to me, right? But the target system is actually going to be your data governance data. To answer your question, the data analysis must be in context of what you're trying to analyze. So if you're trying to do a spend forecasting for your internal procurement department, you're doing a product inventory forecasting for the next 3 months, you must ensure that the data, as I said, it is used after the cleansing of quality. Once it is into your MDG system, and also you have your inventory database updated from the source data. The source data, the raw data, the unclean data will never ever be used directly for analysis, especially for critical analysis on balance sheet related items or so. Yeah.
Thank you.